Hello guys, I am Vinay Pandey, VKP, Master Teacher in Vedantu, and we shall solve question number 9 of JEE Advanced 2020 Paper 1 Chemistry. And the question says, it is a multi-correct question. It says that in the reaction scheme shown below, Q, R and S are the major products. You can see P is the starting compound on reaction with succinic anhydride followed by AlCl3 gives Q. Q on reaction with the zinc HgScL, which is Clemmensen reduction followed by S3PO4 gives R, and R on treatment with Grignard reagent followed by S3O plus followed by S2SO4 gives S. Now the correct structure we have to find out of S, R and Q, right? Let us start. We can see that this succinic anhydride on treatment with AlCl3, which is a Lewis acid, which coordinates with the oxygen of succinic anhydride, ultimately will produce the electrophile which attacks on benzene ring, right? So what happens? It coordinates, AlCl3 coordinates with the oxygen, and this oxygen gets a positive charge. That's why this bond breaks here. And after breaking a bond, you know that this is the generation of electrophile actually. Now electrophile is generated. This is the electrophile which will attack on our starting compound. Starting compound you see properly because we are going to copy it on the other page. Starting compound is this. Starting compound has one benzene ring, one 5-membered ring fused with this. Here we are having a tertiary butyl group, and here 2-methyl substituents are present, right? 2-methyl substituents. Now this electrophile will come. Electrophile is an acylium cation actually, right? Which is, AlCl3 is already coordinated. This electrophile will attack at ortho position of this group. You see, this group is the best group because it is having 2 alpha H, and it is the best donor out of these 3 groups, and its para position is already blocked, and that's why ortho will be attacked. So it attacks at ortho position. After attack at ortho position, what you get is that you see you get one carbon which is having C double bond O. This attacks, right? Then 1, 2, 3, 4 total 4 carbons are coming from anhydride, and this is AlCl3, right? AlCl3 minus, and this H will not be there. This double bond is not there, and hydrogen is there, right? Plus charge. This hydrogen will be fired. After firing of hydrogen, this aromatic ring attains its aromaticity, and after attainment of aromaticity, this 1, 2, 3, 4, this group becomes COOH, and here one C double bond O is there, right? This compound is Q, right? So let us check what structure they are giving for Q. Q is this one. This is the correct answer. Q is the correct answer which we have found. Now this compound undergoes Clemmensen reduction, and after Clemmensen reduction, this C double bond O, ketone, will go, and when ketone goes, you see that this is benzene ring, here 2 methyls, here one tertiary butyl substituent, and this ketone goes 1, 2, 3, 4 carbons are there, and this is COH as such, right? Ketone goes. Now S3PO4 they are employing. S3PO4 is an acid. This acid will basically protonate at OH, and H2O is out, and this carbon ultimately will get a plus charge, and then it will make ring closure on the benzene ring. But please keep in mind, with the presence of this group, with the presence of this C double bond O, which was electron withdrawing group, this Friedel-Crafts acylation was not possible, and that's why we had to do this Clemmensen reduction so that C double bond O is out. In presence of EWG, benzene doesn't undergo Friedel-Crafts acylation or Friedel-Crafts alkylation, both. Now this ring closure will very clearly occur in the presence of S3PO4. So after this ring closure, ultimately what you get is, this is the basic fundamental structure which were given in starting. Now one 6-membered ring is further attached with benzene ring along with the C double bond O here. This is the benzene ring which was already present. This is supposed to be S. This is supposed to be R. This is R. So let us check what they have given for R. There is only one option given for R which is incorrect. So option C is not the correct answer. Let us check. Let us continue. This R is actually attacked by methyl magnesium bromide, that is a Grignard reagent, followed by S3O plus. Grignard reagent is always followed by S3O plus in general, because after attack this CH3 minus will attack, this CH3 minus will attack on this carbonyl carbon, and this OH O minus, this O becomes O minus, which after getting H becomes OH. So ultimately what you get, you get, this was the benzene ring already, right? This is methyl tertiary butyl 1, and you are getting one OH and one methyl, which on treatment with H2SO4, which is a dehydrating agent, after removal of H2O from here, from OH, you will get an alkene, right? So at the last, this product which is supposed to be S is this one. You see, this is a methyl along with a double bond which is formed here. This was tertiary butyl substituent, and there are 2 methyl substituents, right? This is supposed to be S. Let us check. They have given 2 structures for S, A and D, out of which D is the correct answer. So our answer for this question is B and D. Understood? It is a very simple reaction sequence. You see, let us repeat. Succinic anhydride on reaction with AlCl3 will create an electrophile. This electrophile attacks on benzene ring, but our benzene ring is having different substituents. One tertiary butyl, one side there is a 5-membered ring, which first carbon of 5-membered ring which is directly connected to the benzene ring is having 2 methyl, no alpha H. Other carbon which is directly connected to the benzene ring is having 2 alpha hydrogens. So this is supposed to be the best electron donor, and that's why new electrophile will come according to this one only. This particular carbon which is having 2 alpha H will actually direct the new incoming electrophile, and it will direct the new incoming electrophile to ortho position. Why? Because its para is already blocked. So ortho, this electrophile is attached to ortho, and after retaining aromaticity, after firing H plus, it becomes COOH, and ketonic group is already there. Now on treatment with Clemmensen reagent, this ketone will go, it becomes flat alkane kind, and COOH is there. S3PO4 will basically take out this OH and makes a positive charge here, where this ring will attack. It is an electrophilic aromatic substitution, Friedel-Crafts acylation reaction, and ring closure occurs with a ketonic group again. And methyl magnesium bromide Grignard will attack on this carbonyl carbon, followed by S3O plus means OH. It becomes a tertiary alcohol. Tertiary alcohol on reaction with H2SO4 heating, it will dehydrate. It is an even reaction with the formation of carbocation. It will give an alkene. So our structures for Q, R and S are clear, out of which they have given Q and S correct, and R from their options is incorrect. Okay, understood? So this way the answers for this question is B and D.